Hi everyone, it's me, Dr. V, and it's a good day to do some AP Chemistry exam review. In this webcast, I'd like to work through free response question number 6 from the 2024 exam. Now, starting with the 2025 exam, there are some changes coming. This year's exam will be given in a hybrid format. That means the multiple choice will be done completely online using the Blue Book app, and the free response questions will be presented to you online, but you'll actually be writing your answers on paper in an answer book. It's also worth mentioning that you will have a paper periodic table for the entire exam, but the reference sheet that we all love and use so much will only be available digitally. You'll have that throughout the entire exam, but you'll have to pull it down in the Blue Book app. It is tabbed. And you'll have access to the online Desmos graphing calculator throughout the entire book. It's embedded into Blue Book. You'll also have the option of using a handheld calculator. I also want to mention you will have scratch paper to use during the multiple choice questions. In terms of this webcast, like I said, we're going through free response question number 6 from the 2024 exam. Now, this is one of the short free response questions, which means it's scored out of 4 points. You should be thinking about 7 or 8 minutes to do the question, and it's probably going to have 3 or 4 parts to it. Before we go any further, grab your calculator, your periodic table, your formula sheet, some paper to write your answers on. What I want you to do is to listen to me introduce each part of the problem, and then I want you to pause the webcast. Try to answer it on your own. I know. Try to answer it on your own, and then listen to my explanation or my solution. And then you can score your own work, your answer to each part. Did you earn the point? Did you not earn the point? How do you need to improve your answer or enhance your answer to make sure you're going to get full credit? Let's jump right into the question. At elevated temperatures, nitrogen dioxide undergoes decomposition in the gas phase, forming nitrogen monoxide and oxygen gas as represented by this equation. A scientist measures the change in the molarity of the nitrogen dioxide gas over the first 100 seconds of the reaction at 546 degrees Celsius. The scientist uses the data collected from the experiment to generate the following 2 graphs. So here's graph 1, here's graph 2. What jumps out at me right away is that the right-hand graph is linear, the left-hand graph is not. Is that going to be important? Oh, yes. Based on these data, the scientist makes the claim that the rate law for the reaction is second order in NO2. Explain how the graphs indicate that the reaction is second order with respect to the nitrogen dioxide. So as we pointed out before, the left-hand graph is not linear, the right-hand graph is. But that's not how you need to word your answer here. This is really important. What you need to remember is that when a reaction is first order with respect to a particular reactant, the graph of the natural log of the concentration versus time will be linear, and the other graphs that you could make would not be. If the reaction is second order with respect to a particular reactant, what we see then is that the graph of 1 over the concentration of the reactant versus time is linear. Clearly, the right-hand graph, which has 1 over the concentration versus time, is linear. That's what you need to say. The graph of 1 over NO2 molarity versus time is linear, and that's consistent with the reaction being second order with respect to NO2. So really talking about what information is plotted in the graphs, which one gave you linear data. That's what you needed to say to earn the point here. At a certain point in the reaction, the rate of disappearance of nitrogen dioxide is determined to be 6.52 times 10 to the minus 7 molar per second. Determine the rate of appearance in molarity per second of oxygen gas at this same point in the reaction. So what this part of the question is really about is the relative rates. And it comes down to that balanced equation. What we see is that for every 2 nitrogen dioxide molecules that decompose, 1 oxygen molecule is formed, right? It's a 2-to-1 ratio. And so really all we have to do is use that ratio to find the rate at which the oxygen appears. What I need to do is take that 6.52 times 10 to the minus 7 and divide it by 2. To get the rate of the oxygen. Now I set it up here as a factor label. You just need to show a setup, divide by 2. You get an answer of 3.26 times 10 to the minus 7th. The units are molarity per second. It's kind of implied the way the problem is set up, but this is the work and the answer that you need to get 1 point for part B. And it goes on. NO2 is a molecule that contains an odd number of electrons, and it can be oxidized to form the NO2 plus ion. In NO2, the unpaired electron is presumed to be localized on the nitrogen atom, as shown in the Lewis diagram on the left. And then we have a box for the NO2 plus ion. You can guess what's coming, right? In the box on the right, complete the Lewis diagram for NO2+. Be sure to show all bonding and non-bonding electrons. So draw a Lewis structure. These are things that AP students need to be able to do. The first thing to do is to count valence electrons. How many are there in the ion? I have 6 from each of the 2 oxygen atoms. The nitrogen atom would contribute 5. The overall ion has a +1 charge, so I have to take 1 out, giving me 16 valence electrons in the structure that I'm trying to draw. The other really important thing to remember is that nitrogen, oxygen, carbon, and fluorine atoms, when you're drawing Lewis structures, are always going to obey the octet rule. They're always going to have 8 electrons around that central atom. So the best way to draw that structure, you're going to have double bonds between the nitrogen and each of the oxygens. That gives the nitrogen an octet. You're going to have 2 lone pairs on each of the oxygens. That gives each oxygen an octet. All 16 electrons are accounted for. We've got our +1 charge accounted for. We're good to go. That's what you needed to draw to earn 1 point. There really aren't any other possible structures. A student makes the claim that the bond angles in the NO2 molecule, which is the one in the left box, and the NO2+ ion, which we just drew, are different from each other. Do you agree or disagree with the student's claim? Justify your answer. I agree with the student. You need to make sure that you're answering the question that's being asked. When I first read the question, I misread it. We're asking, are they different? Yes or no? I agree. They are going to be different. But how do I know that? What should I write? Well, I like to think about how many electron domains are around my central atom. So in the left-hand molecule, the NO2 molecule, there are 3 electron domains around the central atom. I've got 2 atoms bonded, and then I've got that single electron. But it's still 3 electron domains. Now, I could also talk about the nitrogen being sp2 hybridized. I don't need to do both of these. I need to do one of them. Either way, I'm going to decide that this would give me a bond angle of 120 degrees. For the NO2+ ion, I have 2 electron domains around that central atom, right? I've got 2 oxygen atoms bonded to the nitrogen. There's no lone pairs. There's no weird lone electrons. There's just the 2 electron domains around the central atom. I could talk about the nitrogen being sp hybridized because there are 2 electron domains around the central atom. All right, again, I need to do one of these, but not necessarily both. But either way, I'm going to come to the conclusion that I would have a 180-degree bond angle. Well, 120 and 180 clearly aren't the same. Right, I agree. The bond angles are different. This is what you needed to talk about to get the 1 point for part 2 here. How did you do? The average score on this question in 2024 was 2.26 out of 4. So if you earned 2 points, you're just fine. If you earned 3 or 4, you're doing well. If you didn't get the score that you wanted, make sure you go back and review kinetics. It's an important topic. Make sure you can draw Lewis structures. Make sure you review your bond angles. Make sure you review VSEPR geometries. They all sort of tie in together, at least in this question. If you found this helpful, like the video and leave a comment. And remember to subscribe to my channel so you get all my latest updates. Have a great day and keep studying chemistry.